Now let us look at some modeling complexities in routes. Now when we are talking about the modeling complexities, we are actually looking at the mathematical models or the analytical models for the routing. There could be a complexity of a single and multiple routes. So one factor we need to consider is the consideration of a single or multiple routes between the shipments from the origin to the destination, of course. So there can be one single preferred route, or there can be many alternate multiple routes as well. We also need to, as a modeler, we also need to look at the linear and non-linear costs. So linear and non-linear transportation costs, it actually add further complexity to the intermodal transportation systems. Transportation costs can be modeled as a linear fixed cost per unit, that is for miles, pound, weight basis, or it could either be the non-linear one. So it depends upon that whether the assumption of linearity is okay for your type of transportation, or does the cost increase or decrease non-linearly. So modeler, the mathematical modeler or analytical modeler, they have to look at the nature of the transportation cost. Non-linear transportation costs such as quadratic cost functions or exponential cost functions are more realistic. So your cost might be increasing or decreasing exponentially, or your cost is increasing or decreasing non-linearly as a quadratic cost function. So we need to look at it, that whether we have to use non-linear cost approximations or linear cost approximations. Of course, we cannot take every cost into linear cost regime. There might be some costs that fall in the regime of non-linearity. So to model them would be a challenge, because in a mathematical model you need to incorporate it, and it will create further complexity. Let us take an example to clarify the concept. Assume that the distance between cities A and B is 100 miles, and the distance between cities B and C is 100 miles as well. In a linear cost model, the transportation cost might be 20 cents per mile. A non-linear model might include a cost break at a 100-mile point, where the transportation cost up to and including 100 miles is 20 cents per mile. But the per mile cost for distance over 100 miles is 15 cents per mile. So what has actually happened? Your cost is not increasing linearly. It is actually increasing in a non-linear fashion. So if there is a break of 100 miles, you have to pay 20 cents per mile, but above 100 miles you have to pay a lower cost per mile. So your overall cost would be non-linear. So the cost to transport goods from city A to city C directly will be $40, because there is what is the total distance from A to C then? That would be 200 miles. 100 miles from A to B, and then 100 miles from B to C. And for the same distance, if someone uses the non-linear cost model or the cost break, the cost would be $30. You can verify it, because now above 100 miles, because you are moving 200 miles, so you would be paying 15 cents per mile. It could either be the third option as well. That is, for the first 100 miles, you might be paying 20 cents per mile, and for the next 100 miles, you might be paying 15 cents per mile. In both cases, the cost would be lower. In this case, the cost would be lower than the linear cost model. Also, the number of options available to get the final destination increases because of non-linear costs. What does it mean? It means we can have different options to reach our destination if we are using a non-linear cost model. But at the same time, the challenge would be to find the optimal cost after including such complexity like non-linearity of the cost in your mathematical model. Thank you.